In this video, we're going to go through enthalpy, entropy, and Gibbs, or delta H, delta S, and delta G. The question that we're going to answer is how can energy changes help us predict whether a chemical reaction will happen on its own? So the first topic that we're going to hit is enthalpy, which is delta H. So enthalpy is the heat of a system. If your enthalpy is greater than 0, meaning it's positive, it's going to be endothermic. It will be absorbing heat from the surroundings. If your delta H, or your enthalpy, is negative, that means your reaction is exothermic, and it's going to release heat. So we'll get into this in a later lesson, but you can find your values for delta H using the formula delta H equals the sum of your delta H values for your products minus the sum of your delta H values for the reactants. All right, entropy is a new topic, and it is the measure of disorder in a system. If you have more disorder in a system, you're going to have higher entropy. Entropy increases as matter changes from solid to liquid and then to gas. So if you think about the three states of matter, when you have a solid, all of the particles are relatively close together and they're combined. When they are a liquid, they are spread out a little bit further, a little more disorganized. When you get into the gas phase, those particles are all over the place, bouncing around, and that is definitely more disorganized than the earlier stages. So the second law of thermodynamics is the universe tends toward greater entropy or disorder. The formula to find entropy is very similar to the formula to find enthalpy, where we were taking all of our values for the products, adding them up, and subtracting all the values for the reactants. We find delta S using the same formula, but instead of using the enthalpy values, we're going to use the entropy values. So here's an example. We have a chemical reaction, and it's asking us to determine our entropy. So we're given some values here for all of the entropy values. Now notice it's the number of joules per mole. So in our reaction, hydrogen has 3 moles and NH3 has 2 moles. So when we go to find our entropy, we're going to multiply each value by the number of moles. So we can find delta S by doing products minus reactants. So our products are NH3, so we have 2 moles, and we're going to multiply that by its value, which is 192.5. I'm going to leave my other units off here. It's going to get a little crowded. Then we're going to subtract the reactants. So we only have 1 mole of nitrogen, so that's going to be 191.5 minus, oops, I'm sorry, not minus. We're going to add that to our other values. So we have 3 moles of hydrogen. 3 moles of hydrogen. Hydrogen's value is 130.6. Okay, so when I multiply on the left-hand side, 2 times 192.5 is going to be 385. And when I multiply this out, let's see, so we'll have 191.5 plus 3 times 130.6 is going to be 391.8. So when I do the math here, this will simplify out to negative 198.3 joules per Kelvin. Okay. Now, Gibbs free energy tells us the spontaneity of the reaction, whether or not it's going to happen on its own. If delta G is less than 0, it is a spontaneous reaction, meaning that it does not require additional energy for the reaction to take place. It's going to happen on its own. If delta G is greater than 0, it is non-spontaneous, so it's going to require some additional energy for the reaction to take place. The formula that we use to find delta G is delta H minus T, which the temperature here has to be in Kelvin, times delta S. And delta S must be in kilojoules. Okay. So to convert our delta S from joules to kilojoules, we're just going to divide that value by 1,000. So in our previous example, we had joules per Kelvin. So if we have joules per Kelvin, we just divide that by 1,000 to get our value in kilojoules per Kelvin. To convert our degrees Celsius to Kelvin, we are going to take our degrees Celsius and we're going to add 273 to that to get our Kelvin. So here we added 273 to get our Kelvin. All right, so let's do an example where we're going to have to do all of this to figure out our Gibbs free energy. So we're given an equation and we're given a table of values. We have our delta H values and we have our delta S or our entropy values. So we're going to need to calculate delta H using the values from the table. We'll need to calculate delta S using the values from the table. We're going to need to convert our temperature to Kelvin, and then we'll need to plug everything in. So let's start with delta H, or our enthalpy. So products minus reactants. So our product is BaCO3. So that's going to be our value on the left-hand side of our reaction. So, or our equation, 216.3. Products minus reactants. So here, everything has a coefficient of 1, so that makes things kind of easy. So negative 553.5 plus, we have a negative 393.5. All right, so we plug all of these values in, and we get negative 269.3 kilojoules per mole. Or, I'm sorry, just kilojoules, because we've already canceled out our moles, or we would have if we wrote in our 1 mole for each of our pieces here. Okay, delta S, or our entropy, we're going to use again our values from the table. So products minus reactants, so we had 112.1 minus our reactants, so 70.42 plus 213.6. So when I plug this into my calculator, I get negative 171.9 joules per Kelvin. Now here we want to convert this to kilojoules, so we're going to divide by 1,000. So here we would have negative 0.1719 kilojoules per Kelvin. Okay, and then our temperature was 25 degrees. So 25, we want to add 273 to that to get our temperature in Kelvin. So if I add that, that will give me 298 Kelvin. Now it's just a matter of putting everything together. So our equation is delta G equals, we have delta H minus our temperature, delta S. So our enthalpy, or our delta H, was negative 269.3 kilojoules. Our temperature was 298 Kelvin. And our delta S was negative 0.1719 kilojoules per Kelvin. So now it's just a matter of plugging into our calculator. When we do this carefully, we get negative 218.1 kilojoules. Okay, now if you recall, for our Gibbs, if it's less than 0, it's spontaneous. If it's greater than 0, it is non-spontaneous. So because it is negative, it is spontaneous. And that's it. That's how to find enthalpy, entropy, and Gibbs free energy.